All right, so we're good at writing numbers. We're good at understanding the level of uncertainty with those numbers. Now let's move into the realm of making calculations and understanding what those calculations mean. In order to get started with that, I want to introduce a tool called dimensional analysis. And really, dimensional analysis is pretty simple. It's just a trick that will allow us to carry out unit conversions and also figure out the final units of any numbers that we calculate. So go through a big complicated calculation. You want to understand what that final number means. That's why we use dimensional analysis. All right, so here's the big take home with dimensional analysis. So the main idea is that whenever you multiply or divide numbers, you're allowed to treat units just like algebraic variables. Or when I say algebraic variables, that's just a fancy way of me saying numbers. Okay, so let's say you've got two numbers. You've got a number x and a number y. X and y can be anything, but we're assuming that they're different because we're using different variables. And we can absolutely divide y by x, or sorry, divide x by y. We can do the same thing with units. Let me show you what I mean. Let's say we had a car. Okay, the car drives 30 miles. And when the car drives 30 miles, it uses 2 gallons of gasoline. All right. Well, we can divide these two numbers. If we want to find the fuel economy of the car in miles per gallon, we would want to divide these two numbers. So let's do it. 30 miles divided by 2 gallons. Well, 30 divided by 2 is 15, so we know our final result is going to be 15, but what will our final units be? Well, dimensional analysis says you treat units just like algebraic variables, so we can write our final units as simply miles divided by gallons, or miles per gallon. Super simple. Okay. You can also multiply units. Just as you can divide units, you can also multiply units. So, for example, you can multiply two variables. You can also multiply two units. And let's start with the number that we had before. So 15 miles per gallon is the fuel economy of our car. But let's say we're no longer talking about a car. We're actually talking about a bus. And maybe we want to account for the fact that the bus doesn't just carry one person. We want a measure of the overall carrying capacity of the bus, and the bus actually carries 10 people, or 10 passengers. So 10 passengers. Okay. Well, one way to sort of, calculate a measure of how much carrying the bus can do is to multiply these numbers. You don't need to worry about that too much. I'm really just focused on what we do with the units when we multiply and divide numbers. But let's say we want to multiply the number 15 miles per gallon by 10 passengers. Okay, so just write the multiplication symbol in there. We would end up with 150, right? 15 times 10 is 150, but what are the final units? Well, essentially, you're going to end up with 2 units in the numerator and 1 unit in the denominator. So I could write these final units as passenger miles per gallon. Passenger, write a little multiplication sign, miles per gallon. Okay, so just as I would, multiply 2 variables, I can multiply units, and I end up with 150 passenger miles per gallon. And this is actually a very common set of units for measuring the fuel economy of things like buses and trains and airplanes and things like that. You tend to not use so much miles per gallon, but you tend to look at things like passenger miles per gallon. Okay, all right, and then the last big idea with dimensional analysis comes from the idea of what happens when you take a variable and you divide that variable by the same variable. So like x divided by x, right? Well, we all know from past math classes that anything divided by itself is equal to 1. In other words, an x cancels out another x, and you end up with 1. Okay, units do the same thing. Let's take the example of, let's go back to 15 miles per gallon for our car. 15 miles per gallon. All right, and let's say we have another number which is a certain amount of gasoline. 10 gallons of gasoline. All right, we could absolutely multiply these numbers. 15 miles per gallon times 10 gallons. What are the final units going to be? Well, we end up with 150 again, because 15 times 10 is 150. And we're going to end up with units of miles, mile, gallons, per gallons. Okay, but we know that we can treat units just like variables, and gallons will actually cancel out with gallons. Gallons divided by gallons is equal to 1, and we actually end up with a final number, 150, with units of just miles. It turns out that when you multiply the fuel economy in miles per gallons times a certain amount of fuel, it will tell you the number of miles that could be driven using that much fuel. So 10 gallons will actually drive us 150 miles. And the actual numbers and the meaning of those numbers isn't super important for this video, but what I want you to understand is how gallons cancels out with gallons and how we know that our final answer is going to end up with units of miles. This will actually provide us with lots of information about what our numbers mean when we go through the calculations. And it will also help us because if we get units that don't make sense, it probably means that we made a mistake when we set up the problem. So that's dimensional analysis. We'll take it from there in the next video.